Section 55 is entitled Stoke's Theorem. Stoke's Theorem. The theorem basically states under certain conditions that an integral over some region C of f dot, say, t ds, or f dot dr, let's do that instead. F dot dr is the same as the integral of the curl of f. I guess we have to dot it with n. Dotted with the normal ds. Now, suppose you want to evaluate f dot t ds, both as a line integral and a double integral. And you are told that f is negative y plus z, x minus z, and x minus y. And that the surface is z is equal to 1 minus x squared minus y squared. So this says that z is not negative, because this is never negative. So if I square both sides, I get this, where z is not negative. Bringing the x squares and y squares to the left side, you get this. For z happens to be non-negative. This last line, including the constraint that z is bigger than 0, that's exactly the same as the first one. You have to say z is not negative. Okay. So now let's evaluate this as a line integral. How about we let x equal cosine t and y equals sine t. Then x squared plus y squared will equal 1. But then dx will be negative sine t dt, negative sine t dt, and dy would be cosine t dt. So the integral of f dot dr will equal to, from the previous theorem, negative y dx plus x dy over RC. But negative y would be negative sine t, and dx is negative sine t dt. Negative times the negative will cancel out, and the sine t times the sine t gives you sine squared t dt plus x dy. Well, x is cosine t times dy, which is times another cosine t dt. But here we can factor out the dt, and we get this times dt. But this here is good old 1. And the integral of 1 dt is just t. And since we want x squared plus y squared, and if z is 0, for example, x squared plus y squared is 1. It's the whole entire circle. That is the angle goes between 0 and 2 pi. T has always been going between 0 and 2 pi. And this is just equal to 2 pi. So we did the integration of a line integral, and we got that this is 2 pi. Instructions is to verify Stoke's theorem. So now I integrate using the curl. Well, this here is M, and this here is N, and this here is P. And actually, what we want to look at this equation. X squared plus y squared plus z squared take away 1 is 0. Well, what's the normal of that? You know, the normal would be the partial with respect to x in the y direction plus the partial of this with respect to y in the j direction plus the partial with respect to z in the k direction. And this gets divided by its length. This squared will be 4x squared plus this squared is 4y squared plus this squared is 4z squared at square root of that. So if we look at that more closely, we could factor out a 4, and then we get x squared plus y squared plus z squared. But this is 1. So it's just the square root of 4, which is 2. And I can factor out a 2 from the top. I get 2 times xi plus yj plus zk divided by 2. And of course, the 2's are going to cancel. The 2's are going to cancel. And n is actually a vector. So that's n. That's n. So now we need to find zx and zy. So we know that z squared, after just solving our surface for z, z squared is equal to 1 minus x squared minus y squared. 1 minus x squared minus y squared. So now, what is z sub x? So 2z z sub x is equal to negative 2x. So z sub x is negative 2x over 2z. And of course the 2's cancel out. It's negative x over z. And z sub y is going to be symmetrically the same. It's going to be negative y over z. So what I want to find out is what's the square root of 1 plus z sub x squared plus z sub y squared. So we have the square root of 1 plus z sub x squared, which is x over z squared. Doesn't matter if I use the plus or the minus, plus this, plus y over z squared. Square root of that. But 1 is the same as z squared over z squared. plus x squared over z squared plus y squared over z squared. So everything's over z squared. So the top is z squared plus x squared plus y squared. Square root of that. But the top is 1. 1 over z squared. The square root of that, which is the square root of 1 divided by the square root of z squared. The square root of z squared is the absolute value of z, but we've always said that z was not negative. So this mess is 1 over z. Basically, ds equals the 1 plus the x over z squared plus the y over z squared dA. That is, ds is 1 over z dA. ds is 1 over z dA. Okay. Now, if you computed the curl of f, you get 2k. So now, the curl of f dotted with n. Remember, it turned out that n happened to equal x, y, z. And the curl of f is 0, 0, 2k. So you dot these. You multiply the first component, so you get 0. You multiply the second component, so you get 0. You multiply the third component, which is just 2, you get 2z. You add those up, you get 2z. So that's what I'm supposed to integrate. Supposed to integrate the curl of f dot n ds. But the curl of f dot n is 2z. And ds is 1 over z dA. The z's, of course, cancel. And you're integrating 2 times 1, which is 2, which I'll bring in front, dA. But that's just the area. That's just the area. What area? The area of the circle. With radius equals 1. Well, the area of any circle is pi times r squared. This is pi. 2 times pi is 2 pi. Exactly the same answer we got before. So they are, in fact, both equal. They both equal 2 pi. Okay, let us try another problem. We'll just do one more. That will actually complete the Calc 3 video. So, the instructions are, for this problem, is to use Stoke's theorem to evaluate f dot dr, where they tell you that f of x, y, z happens to be x squared y squared, actually z squared x squared y squared, excuse me, z squared x squared y squared. That's a bit more interesting. And the surface is where z is equal to 4 minus x squared minus y squared. And z is greater than or equal to 0. So we want to evaluate this using Stoke's theorem. Well, this is equal to double integral of the curl of f dotted with n ds. Okay, that is Stoke's theorem. So we have to find the curl of f and n. First thing you do is you get that equal to 0. Call that g. G of x, y, z. And it's going to be x squared plus y squared, and bring everything to the left, plus z is minus 4 equals 0. Plus 4, excuse me, equals 0. Well, since I'm bringing it to the left, excuse me, minus 4. But that won't even matter. Because the gradient of g is 2x, 2y, and 1. But that's n. That's n. So now we can find the curl of f. I'll just give you that as 2y, 2z, 2x. Now, what is the curl of f dotted with n? So you have 2x times 2y, which is 4xy, plus 4yz, plus 1 times 2x, of course, is 2x. That's what the curl of f dot n is. Well, if I take the double integral of both sides with respect to s, what happens? Now, in this case, if you think about it, s is a. So it is just dA. Alright. What is the area that we are integrating? Well, you know that z is equal to 4 minus x squared minus y squared. That is, z is 4 minus these circles. These circles. In fact, bringing the z over and the x squared plus y squared over, you get that 4 minus z is x squared plus y squared. With respect to the z-axis, let the 0 be there. When z is 0, then x squared plus y squared is 4. So you get a circle of radius 2. When z is 2, this will be 2, and x squared plus y squared is 2. That is, you get a circle of radius square root of 2. I hope I said up here that down here the radius was 2. When z is 0, this is 4. So x squared plus y squared is 4. That is r squared. This is r squared. It's 4, so r is 2. When r squared is 2, When that happens to be when z is 2, get r to the square root of 2. Now if z is 3, 4 minus 3 is 1. So x squared plus y squared equals 1, which is a circle of radius 1. And when z is 4 itself, this is 0. So basically, getting this cone-like figure. And what is x and y going from? Well, they're circles. So, for example, if instead of dA, I choose to use dy dx, well, we know that x squared plus y squared in the xy plane is equal to 4. So that means y squared is equal to 4 minus x squared. That means y goes in between negative the square root of 4 minus x squared and positive 4 minus x squared. Less than 4. Less than. So, that's the lower limits. The square root of 4 minus x squared, or negative that, up to 4 minus x squared. And y goes from negative 2 to positive 2. And that's the integral that you would evaluate, which we'll do. One more time. Boom. Okay. So first we integrate with respect to y. So it's an integral from negative 2 to 2. I do the innermost first. Integrate 4xy with respect to x. I'm going to get 2x squared, 2xy squared, plus 2yz. And we are told that z is one thing wrong. Shucks. I stated that the curl of f was 2y, 2z, 2x, and that n was 2x, 2y, 1k. So when you dot these, you should get 4xy plus 4yz plus 2x. Somehow down here, I put 2z. It's 2x. Now, the one thing that I should state first is, just in case z is in terms of f, z is in terms of y, we need to get rid of the z right here. But we were told what z equaled. Z was equal to 4 minus x squared minus y squared. So it's the double integral of 4xy plus 4y times z, which is 4 minus x squared minus y squared, plus 2x dy dx. So let's clean that up a little bit, and then we'll integrate. This becomes 4xy plus 16y minus 4x squared y minus 4y cubed plus 2x dy dx. We integrate with respect to y, and we get 2xy squared plus 18y squared minus 2x squared y squared minus y to the 4th plus 2xy. And since we integrated, it shouldn't be there anymore. The integral's fine. And y goes from negative the square root of 4 minus x squared up to 4 minus x squared. And then we do dx. So let us substitute in what y is. Remember, y goes from plus minus 2. X goes between plus minus 2. Now, let's notice that this has an even power of y, and this has an even power of y, and so does this, and so does this one. So when you plug this in or that, you're going to get the same answer. And then you subtract. So it's just a matter of plugging it in here. And if you think about it, you'll get 2 times the square root of 4 minus x squared. I factor out the 2x. So in the upper limit, you get the square root of 4 minus x squared minus this, which is minus, so it becomes plus the square root of that. So this is just 4x square root of 4 minus x squared. So this is the integral from negative 2 to 2 of 4x square root of 4 minus x squared dx. But I wouldn't dare integrate this. I have better things to do with my time. This is an odd function. If you plug in 5 or negative 5, the answer will differ by a negative sign. Whenever you have an odd function, what happens to the right is 0, happens to the left is 0, but it's negative. And for the record, if to the right is 0 is like that is, it can be negative sometimes and positive sometimes. If it's an odd function, then you would have this, where it's positive to the right is negative to the left. Positive to the right, negative to the left. Well, if you go from negative a to positive a, the areas cancel out. This area and this area cancel out. Maybe that area is 5, but this area down here is negative 5. This area is negative, this is the same positive. It's 0. And since we're going from a negative number to the same positive number of an odd function, this is 0. Think about why it's odd. Before you do any problem, think for a few moments. Can I not really do it and get the right answers? And in this case, yes, you can. Yes, you can. Answer is 0. On that note, this completes the Calc 3 video. I hope you learned a lot and the video was helpful. Good luck on your finals. Okay, thank you.